Good morning, friends, and welcome to this lecture on electronic switching devices. In the last lectures, we have dealt with unijunction transistor and field effect transistor. So we studied these two devices with regards to their construction, characteristics, and applications. Now the third switching device or the solid state device that we are going to learn is the silicon controlled rectifier. So silicon controlled rectifier is called as the SCR. So silicon controlled rectifier is nothing but the SCR. So what is the SCR? SCR is a three-terminal semiconductor device that we have seen. The UJT has also got three terminals. Field effect transistor also has got three terminals, and this SCR also has got three terminals. So, but this is not a transistor. This is a silicon controlled rectifier. It is a silicon controlled rectifier. Why it is called as the silicon controlled rectifier? We will see in the next slides. So this it is a three-terminal device. SCR is a three-terminal semiconductor device. It acts as a true electronic switch. True electronic switch means, so as soon as the voltage is applied to one of the terminals of the SCR, it can be turned on and off. So there is no time delay in switching the on and off conditions of the silicon controlled rectifier. So the switching is very fast in case of silicon controlled rectifier, that is in case of SCR. Therefore, it acts as a true electronic switch. Third important point regarding the SCR is it can change AC power to DC power, and at the same time can control the amount of power fed to the load. Hence, it is acts as a rectifier as well as power controlling device. So this is the most important feature of this SCR. So it changes AC power to DC power. So the conversion of AC power to the DC power, it is known as the rectification. So it does the function of rectification. It converts AC power into the DC power. We know what are the rectifiers. A rectifier converts AC power into the DC power. Similarly, this silicon controlled rectifier changes AC power to the DC power, and at the same time can control the amount of power fed to the load. So the amount of power fed to the load can also be controlled at the same time. So how much power you want to give to the load, it can be controlled by this device, that is SCR. So this SCR serves two purposes. It functions It is functions for two purposes. One is it acts as a rectifier as well as a power controlling device. So remember, SCR is a rectifier as well as power controlling device, and therefore it is called as the controlled rectifier because it converts its function is rectification, and the power fed to the load can be controlled at the same time. Therefore it is called as the controlled rectifier. Now it is specially made from silicon, and therefore it is called as a silicon controlled rectifier. Generally the germanium controlled rectifiers are not there because the germanium material is very sensitive to the temperature, and therefore thermal stability is not achieved in the germanium material, and therefore these silicon controlled rectifiers are used. So silicon is more thermally stable, means the number of charge carriers generated due to the temperature effect, they are very less in silicon material. Therefore these devices are made up of silicon material. So the important point to remember here is that the silicon controlled rectifier converts AC power to the DC power, and at the same time it controls the amount of power fed to the load. That means it serves two purposes. One is the rectification and other is the power controlling device. And the most important point regarding the SCR is it can handle current up to several amperes and voltages up to 1 kilovolt or more than 1 kilovolt also. So this is the only device which can control the large current and large voltages. No other electronic devices can handle the currents up to several amperes and voltages up to 1 kilovolt or more than that. So it is a power controlling device. Basically, it is a power controlling device, and therefore it controls the higher currents or currents in more than several amperes, up to several amperes, and voltages up to 1 kilovolt. So these are the features of this rectifier. Now how this SCR is constructed. So SCR it is a 4-layer device. It is a 4-layer device. So see in the first diagram, there are 4 layers of semiconducting materials, PN, PN. So it is a 4-layer device. So one PN diode, suppose this PN is the one diode and one NPN transistor. So this is NPN transistor. So one PN diode and one NPN transistor are combined in one unit. So look at this diagram. Suppose this is the PN junction. So this is the PN junction. So it is a diode, and one NPN transistor. This is NPN. So that means one diode and one NPN transistor, they are combined in one unit. So this is constructed like this. So from the base of the transistor, one terminal is taken out. So this is the base of this NPN transistor, and the terminal is taken out from this base, and this terminal is called as the gate. And from the anode of the diode, so from this P region, the terminal is taken out, and it is called as the anode. And from the collector of this transistor, from the emitter of this transistor, NPN transistor, the terminal is taken out, and it is called as the cathode. So this N region is act as a collector, and this P region act as a base for transistor, and this N region act as a emitter for this NPN transistor. So it is a 4-layer device. One PN diode and one NPN transistor are combined in one unit. Now this construction can be visualized as in terms of 2 transistors connected back to back. Suppose this is PNP transistor, PNP. So this is PNP, and take this N again, PG again, and this N, and NPN. So this is NPN. So what is here? So that this the N is acting as a collector, and this is the base of this P. So base of one transistor is the collector of the other transistor. So base of PNP transistor is the collector of NPN transistor, and base of NPN transistor is the collector of PNP transistor. So this is the collector of PNP transistor, and this is the emitter of this PNP transistor. So the emitter of the PNP transistor is called as the anode, and the emitter of the NPN transistor is called as the cathode. So this circuit is again shown here like this. So this is the transistor, this is PNP transistor, and therefore this anode is the emitter. So this P region is emitter. The base of this is the collector of this NPN transistor, and a base of NPN transistor is the collector of PNP transistor, and the terminal is taken out, and that is called as the gate. So this device, it is a 4-layer device. So how many junctions are there? So there are 3 junctions. This is one junction, this is second junction, and this is third junction. So it is a 4-layer device, and it has got 3 junctions. It has got 3 junctions. So this is the 2 transistor analogy of this silicon controlled rectifier, SCR. So this can be visualized like this. So this is the actual construction of SCR, and this is the visualization of SCR in terms of 2 transistor analogy. So these are the 2 transistors connected back to back. These 2 transistors connected back to back. Now see, this is the symbol of this silicon controlled rectifier. So this is the gate, this is the anode, and this is cathode, PN, PN. So there are three junctions, J1, J2 and J3, and this is the symbol of this silicon controlled rectifier, SCR. So this is the symbol is similar to the diode, only one extra terminal is taken out, and that terminal is called as the gate. Now this also has gate, anode and cathode. So this is anode and cathode, and this is gate. So this is the two transistor analogy that we have seen in the first slide. So the two transistors are connected back to back, and the collector flows from anode to cathode. The collector flows from the current flows from anode to cathode, and the this current from anode to cathode means this device can be turned on or off by applying a small gate pulse. We will see it in the working of the transistor. तर अशा पद्धतीने हे जे पिक्चर आहे आपण दोन ट्रान्झिस्टरच्या एनालॉजी मध्ये आपण व्हिज्युअलाइज करू शकतो. सो द करंट, हा जो करंट आहे हा अशा या पाथने फ्लो होईल एनोड टू कॅथोड. सो म्हणजे एमिटर कडून बेस कडे आणि बेस कडून कलेक्टर कडे आणि पुन्हा एमिटर कडे. सो दिस करंट फ्लोज लाईक दिस. So this is the two transistor analogy of this SCR. Now see the characteristics of this SCR. So the circuit required is here. Now the positive voltage is applied to the gate. Now in case of FET we have seen in case of FET we apply the negative voltage to the gate, but here for SCR we will apply the positive voltage to the gate. So this is the gate. So small gate voltage. So small gate voltage is required to turn on the SCR, and small voltage is required to turn on the SCR. So this is the gate connected to the positive voltage, and a high voltage is connected. A high voltage source is connected between anode to cathode. So we have seen this is a power controlling device. It can handle current up to the several amperes and voltages up to the 1 kilovolt. So the voltage applied between anode to cathode is naturally very high voltage, and a small voltage. This small voltage applied to the gate controls the conduction of this silicon control rectifier. So this gate voltage turns on or off this device, silicon control rectifier. So J1, J2, J3, these are the three junctions of this SCR. So this is the symbol of this, and these are the characteristics of this device. So let us elaborate or explain these characteristics. So what are the characteristics? The gate voltage is kept fixed. Suppose gate voltage is kept fixed, and anode to cathode voltage is increased gradually. Anode to cathode voltage is increased gradually. So the anode current is noted, and this is called as the forward voltage. So this is the forward voltage, anode to cathode voltage. This is called as the forward voltage. So forward voltage is applied in steps, and the gate voltage is kept fixed. So if the gate is kept open, let us assume that the gate is kept open, means no voltage is applied. Let us assume that a gate is kept open, and you only increase the anode to cathode voltage. Now see here, this is the positive of the supply, and this is the negative of the power supply. So this P region is connected to the positive, and the lower N region is connected to the negative. So P is connected to the positive, and this N is connected to the negative. That means junction J1 is forward bias. Junction J1 is forward bias. Junction J1 is forward bias. Now see at the junction J2. Now N is connected to positive, and P is connected to negative. That means junction J2 is reverse bias. Junction J2 is reverse bias. So J1 is forward bias, but J2 is reverse bias. And see at the J3, again P is connected to positive and N is connected to negative. That means J3 is also forward bias. So when anode to cathode voltage is applied to this diode, this SCR, when gate is open, no voltage is applied to the gate. The junction J1 and J3 are forward bias and J2 is reverse bias. J2 is reverse bias. So for small applied voltage, actually because of this J2 is reverse bias, no current will flow through the device. No current will flow through the device. So आपण एक असं व्हिज्युअलायझेशन करा की समजा these are the three doors. J1 is one, suppose this is a hall or room, and in this room there are three doors, J1, J2 and J3. These are the three doors, and suppose the J1 is open, J3 is open, but J2 is closed. J2 is closer. So you cannot go from one end to the other end because J2 is closer. J2 is closer. So in similar fashion, when voltage is applied between anode to cathode, J1 and J3 are forward bias, means they are open, but J2 is reverse bias. So there is no flow of current across the J2, and therefore the device is off. The device is off. No actual current flows through the device, and therefore in this graph you will see there is a very small current flowing through the device. So this is a very small current flowing. This is called as the anode current. This is due to the presence of minority carriers. Very small current flows through the device. Now, if you increase the anode to cathode voltage further, suppose anode to cathode voltage is increased further, what will happen? The forward biasing on J1 and J3 will go on increasing, and at the same time reverse biasing on J2 will also increase. So at particular voltage, it is called as the breakover voltage. Suppose the applied voltage is increased up to the breakover voltage. So at the breakover voltage, what will happen? The junction J2 will start breaking down. The junction J2 will start breaking down, and once the junction J2 starts breaking down, the anode current will increase suddenly. The anode current will increase suddenly, and as the anode current increases suddenly, the anode to cathode voltage will decrease. The anode to cathode voltage will decrease. Therefore, at the breakover voltage, junction J2 breaks down and the anode to cathode voltage drops suddenly, but the anode current increases. Suddenly. So in this way, this is anode current increases. So the heavy current starts flowing through this device. Heavy current starts flowing through this device, and we say that the device is turned on. The device is said to be turned on. म्हणजे हे डिवाइस काय झालं? ऑन झालं. केव्हा? when the applied voltage is equal to or greater than breakover voltage. So at the breakover voltage, the device is turned on. म्हणजे when the gate is open, the forward breakover voltage is very large. When gate is open, जेव्हा आपण गेटला व्होल्टेज अप्लाय केलेलं नाहीये, त्यावेळेला फॉरवर्ड ब्रेकओव्हर व्होल्टेज जी असेल, इट्स हॅज अ व्हेरी हाय व्हॅल्यू. So the region of the characteristics, आता हा जो स्मॉल region म्हणजे स्मॉल करंट फ्लो होतोय, so in this state म्हणजे up to the breakover voltage, the device is off, and once the applied voltage exceeds the breakover voltage, the device is turned on, and so device is turned on, but the voltage between the anode and cathode drops suddenly. Therefore, the drop in voltage across the anode and cathode is denoted by this dotted line. So this is the forward these are the forward characteristics of this silicon controlled rectifier. Now, so this region of the characteristics, it is called in this region the device is off. The device is off, and in this state the device is on. So device is turned on. So this is the characteristics when no gate voltage is applied. So when no gate voltage is applied, the forward breakover voltage value is very large. Forward breakover value is very large. Now, if you want to turn on the silicon controlled rectifier at a lower voltage, than its forward breakover voltage, then you will have to apply a small gate voltage. Then you will have to apply the small gate voltage. So let us see. Let us apply some small gate voltage. Now this is the breakover voltage for gate voltage is equal to 0. Now suppose the small gate voltage is applied. So when the small gate voltage is applied, that means the suppose gate voltage is applied, that means P is connected to positive and N is connected to negative. That means junction J3 is already kept in some forward bias condition. Junction J3 is already kept in forward bias condition, and therefore this junction is J3 is forward bias, and this P holes from the P region and electrons from the N region will enter into the P region and they recombine, and here more electrons because this is the this junction is forward bias, so electrons are made available in the P region. Electrons are made available in the P region, and as these electrons are available in the P region, they will be attracted. They will be attracted towards the positive terminal of the battery. They will be attracted towards the positive terminal of the battery, and therefore this junction will starts breaking down at lower voltage. This junction J2 will start breaking down at lower anode to cathode voltage, because the charge carriers are already made available in the P region due to this small gate voltage applied. Due to this small gate voltage applied. And now see again. In the first case we kept gate as open. म्हणजे आपण पहिल्या केस मध्ये काय केलं की गेट ओपन ठेवलं आणि आपण एनोड टू कॅथोड व्होल्टेज आपण ग्रॅज्युअली इन्क्रीज केलं. J1 आणि J3 हे फॉरवर्ड बायस होतील, J2 रिव्हर्स बायस होईल आणि आपण इतकं वाढवलं हे व्होल्टेज की जेणेकरून J2 स्टार्ट्स ब्रेकिंग डाऊन, आणि ज्यावेळेला J2 ब्रेक डाऊन होईल त्यावेळेला या डिव्हाइस मधला करंट काय होईल सडनली इन्क्रीज होईल. तर तो आपण या ग्राफने दाखवलेला आहे बरोबर. पण जर इफ यू अप्लाय स्मॉल गेट व्होल्टेज तर दिस पीएन जंक्शन इज फॉरवर्ड बायस. हे जंक्शन काय झालं आपलं फॉरवर्ड बायस झालं, अँड द करंट विल फ्लो इन दिस पार्ट. द करंट विल स्टार्ट फ्लोइंग इन दिस पार्ट. म्हणजे इलेक्ट्रॉन्स फ्रॉम एन रिजन विल एंटर इनटू द पी रिजन. इलेक्ट्रॉन्स फ्रॉम एन रिजन विल एंटर इनटू द पी रिजन, आणि हे इलेक्ट्रॉन्स एन पी रिजन मध्ये एंटर झाल्यामुळे काय होईल, दे विल बी अट्रॅक्टेड टुवर्ड्स द positive terminal of the battery. म्हणजे they will start crossing the junction J2. The junction J2 which is reverse bias. So the junction J2 will starts breaking down due to the availability of the electrons due to the forward biasing of this gate voltage, and therefore the SCR, this junction J2 will break down at the lower applied voltage. So the junction will break down. Junction breakdown will take place at the lower voltage, and therefore so in this graph you see as gate voltage is applied, the forward breakover voltage is reduced. आपण अजून गेट व्होल्टेज समजा वाढवलं तर अजून फॉरवर्ड ब्रेकओव्हर व्होल्टेज कमी होईल. अजून आपण गेट व्होल्टेज वाढवलं तर आपण अजून फॉरवर्ड ब्रेकओव्हर व्होल्टेज कमी होईल बरोबर. सो द SCR, so in short we can say that the SCR can be turned on. The SCR can be turned on as soon as the gate voltage is applied. अशी आपण एक कंडिशन आणू शकतो की आपण गेट व्होल्टेज अप्लाय केल्याबरोबर हा SCR काय होईल ऑन होईल. हा as soon as gate voltage is applied, the SCR is turned on. So this is the, so that means, so as gate voltage increases, as gate current increases, the forward breakover voltage decreases. So this is called as the region of the characteristics up to which the device is off. That is called as the forward blocking region. And when the device is turned on, it is called as the conduction region, forward conduction region. And this is the leakage current. This is called as the leakage current. Leakage current is very small. So as the gate current increases, the forward breakover voltage decreases. So here one should be remember that once the SCR is turned on by applying some gate voltage, once the SCR is turned on by applying the gate voltage, the gate loses its control. So the gate voltage loses its control means the gate, if even though you turn off the gate voltage, the device will be turned on. तर गेट व्होल्टेज फक्त कशासाठी अप्लाय केलं जातं, टू टर्न ऑन द डिव्हाइस. गेट व्होल्टेज इज अप्लाइड ओनली टू टर्न ऑन द डिव्हाइस, बट वन्स द डिव्हाइस इज टर्न ऑन, गेट लुजेस इट्स कंट्रोल. म्हणजे एकदाच जर डिव्हाइस ऑन झालं तर गेट व्होल्टेजचा जो कंट्रोल आहे त्या डिव्हाइसवरचा तो काय होतो, तो जातो. म्हणजे त्याचा काहीच इफेक्ट होत नाही. मग तुम्ही ते गेट व्होल्टेज वाढवा का कमी करा का झिरो करा. तर गेट सो वन्स द डिव्हाइस SCR इज टर्न ऑन, रिमेंबर मी काय वाक्य बोलतोय ते लक्षात घ्या. वन्स द SCR इज टर्न ऑन द गेट लुजेस इट्स कंट्रोल, म्हणजे गेटचा त्याच्यावरचा कंट्रोल जातो. बरोबर. सो दीज आर दी फॉरवर्ड कॅरेक्टरिस्टिक्स ऑफ दिस SCR. आपण थोडंसं रिव्हर्स कॅरेक्टरिस्टिक्स कडे पण आपण बघूया, की समजा आपण रिव्हर्स कॅरेक्टरिस्टिक्स बघूया. म्हणजे काय रिव्हर्स कॅरेक्टरिस्टिक्स म्हणजे काय, द एनोड इज कनेक्टेड टू द निगेटिव्ह अँड कॅथोड इज कनेक्टेड टू द पॉझिटिव्ह. So when anode is connected to the negative and cathode is connected to the positive, म्हणजे this P region is connected to negative and this N region is connected to the positive. So in that case, junction J1 and J3, हा junction J1 is reverse bias because P is connected to negative and N is connected to positive. So junction J1 is reverse bias. Now junction J2, N is connected to negative and P is connected to positive. So J2 is forward bias. And P is connected to negative and N is connected to positive. Therefore, J3 is again reverse bias. So when anode is connected to the negative and cathode is connected to the positive of this SCR, then J1 and J3 are reverse bias and J2 is forward bias. J2 is forward bias. आधीच्या केस मध्ये आपण काय केलं होतं, एनोड इज पॉझिटिव्ह आणि कॅथोड इज निगेटिव्ह होतं. त्यावेळेला J1 आणि J3 फॉरवर्ड बायस होते, पण J2 मात्र रिव्हर्स बायस होता. आता रिव्हर्स बायसिंग अप्लाय केल्यामुळे J1 आणि J3 आर रिव्हर्स बायस अँड J2 इज फॉरवर्ड बायस. J2 इज फॉरवर्ड बायस. म्हणजे आधी एक दरवाजा ओपन, दोन दरवाजे ओपन होते, एक दरवाजा बंद होता. आता दोन दरवाजे बंद आहेत, एक दरवाजा ओपन आहे. म्हणजे J2 ओपन आहे पण J1 आणि J3 काय क्लोज आहेत. म्हणून आपल्याला म्हणजे जर हे J1 आणि J2 ब्रेक करायचे असतील रिव्हर्स बायसिंग मुळे, तर मग यू विल हॅव टू अप्लाय व्हेरी व्हेरी लार्ज. हॅलो, हा हा असं आहे का? हा बर बर. हा 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 ठीक आहे. दोन कागद घे बरं का. हम्म हम्म हा ठीक आहे चालेल. हा ठीक आहे ठीक आहे. हो हो हो. हा ठीक आहे ठीक आहे. If so if this reverse voltage is increased beyond certain voltage, then the reverse breakdown will take place, and generally this reverse breakdown take place at a very high voltage. So this is the reverse characteristics of this SCR. So reverse characteristics are not important from the examination point of view. The forward characteristics are very important. So here the points to remember is that if the gate current increases, the forward breakover voltage decreases. The SCR can be turned on as soon as the gate voltage is applied. The SCR can be turned on as soon as gate voltage is applied. Now once the SCR is turned on, the gate loses its control. Gate loses its control. So these are the important points you have to remember. So how to, once the SCR is turned on, it loses its control. That means how to make the SCR off, how to turn off the SCR. मग प्रश्न असा येतो की SCR ला ऑफ कसं करायचं. कारण once the SCR is turned on by the gate pulse, gate loses its control. म्हणजे गेट व्होल्टेज तुम्ही झिरो केलं काय किंवा त्याला बंद केलं काय तरी पण आपल्याला SCR ऑफ करता येत नाही. सो हाऊ टू टर्न ऑफ, हाऊ टू टर्न ऑफ द SCR. सो मेथड्स ऑफ टर्निंग ऑफ द SCR. तर काय करायचं, रिव्हर्स द पोलॅरिटी ऑफ एनोड टू कॅथोड व्होल्टेज. म्हणजे आपण जो एनोड टू कॅथोड व्होल्टेज अप्लाय केलेले आहे, सो हे जे एनोड टू कॅथोड व्होल्टेज अप्लाय केले याच्या पोलॅरिटी काय करायला टेम्पररी रिव्हर्स करायचे, चेंज द पोलॅरिटी फ्रॉम दिस एनोड टू कॅथोड व्होल्टेज, राईट. सो रिव्हर्स द पोलॅरिटीज ऑफ एनोड टू कॅथोड व्होल्टेज, किंवा पुट हाय रेजिस्टन्स in series with the anode to cathode and change this resistance such that current through the SCR reduces below the holding current IH. आता बघा आपल्याला याला ऑफ करायचंय, SCR ला आपल्याला काय करायचंय, ऑफ करायचंय. वी हॅव टर्न इट ऑन बाय द गेट पल्स. गेट पल्सने आपण याला ऑन केला. हा ऑन केल्यानंतर हेवी करंट फ्लोज, दिस इज द ऑन स्टेट, बरोबर. मग वन मेथड इज टू चेंज द पोलॅरिटी ऑफ द, या पोलॅरिटीज काय करायचे आपण चेंज करायच्या, चेंज द पोलॅरिटी. आपण ह्या पोलॅरिटी आपण चेंज केल्या. किंवा सेकंडली पुट ए हाय रेजिस्टन्स, एनोड टू कॅथोड मध्ये पुट ए हाय रेजिस्टन्स, आपण हा हाय रेजिस्टन्स आपण पुट केला. आणि हा हाय रेजिस्टन्स जर आपण पुट केला आणि इन्क्रीज द व्हॅल्यू ऑफ दिस हाय रेजिस्टन्स, तर सो दॅट द एनोड करंट रिड्युसेस बिलो द होल्डिंग करंट. आता ही जी करंट व्हॅल्यू आहे त्याला म्हणतात होल्डिंग करंट. सो होल्डिंग करंट इज द मिनिमम करंट रिक्वायर्ड to keep the SCR in the on state. Holding current काय म्हणायचं मग? What is the holding current? It is the minimum current required to keep the SCR in the on state. But if you put a high resistance in series with the anode, and if you increase the value of the resistance, so put a very high resistance in series with this anode and increase the value of this resistance in such a way that the current through the device is reduced below the holding current. Then the device is turned off. So this is the second method to turn off the device. And the third method is switch off anode to cathode voltage momentarily. For a small time, switch off anode to cathode voltage. So using these three ways you can turn off the SCR. आपल्याला तीन पद्धतीने SCR काय करता येतो, ऑफ करता येतो. बघा मी इम्पॉर्टंट पॉइंट काय सांगितला की दी gate voltage turns on the SCR. Gate voltage turns on the SCR means once the SCR is turned on, gate loses its control. म्हणजे गेटचा त्या ठिकाणी रोल संपलेला आहे. मग हाऊ टू ऑफ द SCR? So there are three ways to off the SCR. To make the SCR off, reverse the polarity of the applied voltage. You have put a very high resistance in series with the anode, so that and increase the value of this resistance in such a way that the current anode current reduces below the holding current. Or the third method is switch off the anode to cathode voltage. The anode to cathode voltage switch off momentarily, then the SCR can be turned off. So there are three methods to turn off the SCR. Now, how to turn on the SCR? How to turn on the SCR? Now there are two ways to turn on the SCR. One is to keep the gate voltage fixed and increase the anode to cathode voltage. First method is forward breakover voltage. So keep the gate voltage 0 or at some value and increase the anode to cathode voltage until the breakover voltage. And at the forward breakover voltage, SCR starts conducting. म्हणजे आपण गेट व्होल्टेज 0 ठेवा किंवा keep it at certain values and increase the anode to cathode voltage. So by increasing the anode to cathode voltage, the break at particular voltage, the breakdown of the junction J2 will take place and the device will be turned on. So this is called as the forward breakover voltage method. So keep the gate voltage 0 or at some value and increase the anode to cathode voltage until the breakover voltage, and at the forward breakover voltage SCR starts conducting. This is the one method. Second method is to keep the anode to cathode voltage fixed. Keep the anode to cathode voltage fixed and use the gate voltage to turn on the SCR. So this is most commonly used method to turn on the SCR. So the anode to cathode voltage is kept much below the forward breakover voltage and gate pulse is applied to turn on the SCR. So the anode to cathode voltage is applied below the forward breakover voltage and a small gate pulse is applied, and once the small gate pulse is applied, the SCR can be turned on. So these are the two methods for turning on the SCR. We have seen the methods of turning off and turning on the SCR. So let us see the important terms related with the SCR. So what is the forward breakover voltage and gate trigger current or reverse breakover voltage? So forward breakover voltage, it is the voltage at which the SCR is switched from its off state to the on state. म्हणजे ज्या व्होल्टेजला SCR हा ऑफ स्टेट मधून ऑन स्टेट मध्ये जातो त्याला म्हणतो आपण फॉरवर्ड ब्रेकओव्हर व्होल्टेज. आणि इट इज फॉरवर्ड ब्रेकओव्हर व्होल्टेजची व्हॅल्यू मॅक्झिमम केव्हा असते? It is maximum, the value is maximum when no gate current is applied. जेव्हा आपण गेट पल्स अप्लाय केली नसेल त्यावेळेला फॉरवर्ड ब्रेकओव्हर व्होल्टेज काय असते SCR चे, इट इज व्हेरी हाय. बट व्हेन यू अप्लाय द गेट पल्स द फॉरवर्ड ब्रेकओव्हर व्होल्टेज डिक्रीजेस. आपण त्या ग्राफ मध्ये बघितलेले. नंतर होल्डिंग करंट. व्हॉट इज द होल्डिंग करंट? मी आधीच बोललो. सो इट इज द मिनिमम व्हॅल्यू ऑफ द एनोड करंट टू कीप द SCR इन द ऑन स्टेट. सो द SCR ला आपल्याला ऑन स्टेट मध्ये ठेवण्यासाठी जे मिनिमम करंट लागतं त्याला म्हणतो आपण होल्डिंग करंट. नंतर गेट ट्रिगर करंट. सो इट इज द व्हॅल्यू ऑफ द गेट करंट नेसेसरी टू स्विच SCR फ्रॉम ऑफ स्टेट टू द ऑन स्टेट. So gate trigger current, so it is the minimum or it is the gate current required to turn on the SCR. Then reverse breakover voltage. So again it is the value of the reverse voltage from cathode to anode at which device breaks into avalanche region and starts conducting heavily. So when reverse voltage is applied between the anode and cathode, that and the voltage at which the reverse breakdown takes place, it is called as the reverse breakover voltage. And the value of this reverse breakover voltage is very, very high as compared to the forward breakover voltage, because in forward breakover voltage you will have to break down the one junction, but in reverse bias condition you will have to break down the two junctions, and therefore the reverse breakover voltage is very high. Now so these are the important terms of the SCR. Let us see the applications of this SCR is SCR act as a power controlling device. आपण बघितलं की SCR act as a true switch. SCR act as a true switch because by applying the small pulse to the gate, the SCR can be turned on and it can be turned off. So SCR act as a switch. SCR act as a switch. So this is one application of the SCR. And second application of the SCR is it act as a power controlling device or power controlling switch. It acts as a power controlling switch. Now suppose here is the silicon controlled rectifier SCR which acts as a power controlling device. Suppose this is the load connected to the SCR, and this is the resistive network. This is the resistive network. Suppose this is the sliding point. You can move this point on this resistance above and below. Now when this point is in the upper side, then the gate voltage is higher. When this point is at the lower side, the gate voltage is lower. So by moving this point to the upside or downside, we can say that gate voltage can be increased or decreased. आपण या ठिकाणी हा जो पॉइंट ह्या वरती सरकवला तर गेट व्होल्टेज वाढेल. हा पॉइंट आपण खाली घेतला, हा पॉइंट जर आपण खाली आणला तर गेट व्होल्टेज काय होईल? कमी होईल. आणि आपल्याला माहिती आहे की ऍज गेट व्होल्टेज इन्क्रीजेस, समजा हा पॉइंट आपण वरती घेतला तर गेट व्होल्टेज इज हायर, म्हणजे त्याचं फॉरवर्ड ब्रेकओव्हर व्होल्टेज काय होईल? फॉरवर्ड ब्रेकओव्हर व्होल्टेज विल बी लो. सो SCR विल टर्न ऑन ॲट लो व्होल्टेज. SCR विल टर्न ऑन ॲट लो व्होल्टेज. आणि जर समजा आपण हा पॉइंट खाली आणला तर गेट व्होल्टेज इज लो, so the SCR will turn on at high voltage. Right. So this SCR can be turned on and off at low voltage or high voltage. That means it automatically controls the power fed to this load. या लोडला आपल्याला किती पॉवर फेड करायची आहे, that is decided by the position of this gate on this potential divider arrangement. म्हणजे या पॉइंटवर आपल्याला या लोडला किती पॉवर फेड करायची आहे, it is decided by this gate voltage. So this device acts as a power controlling device. So this is all about the switching devices, that is the UJT, field effect transistor and SCR. So if you have any doubts, you can ask me directly. So this is all about the SCR. Now here our third unit is completed. In the next lecture we will move to the next unit of this course. Thank you for attending the lecture.